Hey there, welcome to another live stream of What If? Yeah, live stream. This week's theme is everything that could kill you in seconds. Sounds about right for What If. No matter what happens, everyone usually dies at the end of one of our stories. Today, we'll look in on what if we lost all oxygen in the world for a few seconds? What would happen if the Earth hit the boiling point for a few seconds? Ooh. And later on, what if all the carbon on Earth disappeared for 5 seconds? Each of these stories has some pretty interesting consequences. For you, not for me. I'm safely here in studio in front of my green screen. Our first story is about what would happen if Earth's temperature dropped to absolute zero. Ugh. Have fun, and picture me here, keeping warm in front of my cozy fireplace. Absolute zero is the lowest possible temperature in the universe. Nothing gets colder than that. So, if the entire Earth suddenly cooled down to the most frigid temperature for even 5 seconds, it would wreak a lot of havoc. Just how cold is absolute zero? What would happen to your body at this temperature? And what's the coolest thing about it? This is What If, and here's what would happen if the Earth dropped to absolute zero for 5 seconds. Temperature is how we measure kinetic energy of the particles in any object. Yeah, it tells us how fast atoms, molecules, and particles move. The hotter a gas, liquid, or solid gets, the faster the particles move. And when that movement slows down, the colder that substance becomes. At the lowest temperature possible, or absolute zero, particles stop moving altogether. This is because at 0 Kelvin, or minus 273.15 degrees Celsius, no heat energy remains. The coldest ground temperature ever on Earth, 184 Kelvin, or minus 89.2 degrees Celsius, was recorded in Antarctica in 1983, but it doesn't even come close to absolute zero. Even the coldest known place in the entire universe, the Boomerang Nebula, 5,000 light years away from Earth, is just a tad warmer at 1 Kelvin. So, are you ready for the coldest 5 seconds ever? At room temperature, that comfortable range of temperatures of about 293 Kelvin, the air molecules move at an average speed of 1,800 kilometers per hour. As the temperatures on Earth suddenly plummeted, all those particles would slow down. At 0.00001 Kelvin, the atomic particles would be moving at a speed of about 0.18 kilometers per hour. That's 1,000 times slower than their speed at room temperature. Getting this close to absolute zero, all chemical reactions would be closer and closer to coming to a complete stop. And this would be very bad news for you and everything else on Earth. Chemical reactions are responsible for everything, including how your brain communicates with your body. Without the trillions of chemical reactions going on inside of you, you wouldn't be able to breathe or turn food into fuel. Temperatures near absolute zero would be devastatingly cold. Even at a comparatively toasty 77 Kelvin, you'd be in serious trouble. That's the temperature of liquid nitrogen. After just a few seconds of exposure to this temperature, you'd suffer severe burns, blistering, and frostbite. Needing a toe or 10 amputated could be a definite possibility. So, just 5 seconds of absolute zero could do incredible amounts of damage to all life forms on Earth. But I have good news. The chemical reactions wouldn't come to a total standstill. Even at the near absolute zero temperature of the Boomerang Nebula, chemical reactions do still appear to take place. This is thanks to the strange effects of quantum physics. And whenever quantum physics is involved, things get weird. To keep you and the planet at 0 degrees Kelvin, even for 5 seconds, you'd need an infinite amount of resources. This makes it mathematically impossible. But that wouldn't mean that 5 seconds of near absolute zero temperatures wouldn't destroy just about everything. And nothing would ever come back together from this soup of atoms that you and the entire planet would turn into. Welcome to hell! Yep, sorry, I meant Venus. Welcome to Venus. Some say it's Earth's twin, but this world is nothing like home. And you're about to experience this scorching hot landscape firsthand. Your mission is to spend 5 seconds on this hellish planet. And trust me, these are going to be a very long 5 seconds. Venus is the second planet from the Sun and our nearest neighbor. At its closest approach, Venus is a mere 40 million kilometers away from us. After just 4 months in space, you'd finally be able to witness this beautiful but deadly planet up close. 4.5 billion years ago, Venus and Earth formed in the same corner of our solar system. This space rock is about the same size as Earth, and its gravity is similar too, but unlike our home, the surface situation on Venus is extreme. We know this because we've sent probes to this scorching world. Some probes orbited it, some made a flyby, and some even landed on the surface of Venus, but those didn't last very long. What happened to them? Well, that's what you're about to find out. Time to make your way down to the surface. Don't these clouds look beautiful? Well, don't inhale them. These yellowish bands streaking across the sky are clouds of sulfuric acid. If you could only get a whiff of them, you'd smell the reek of rotten eggs. But to do that, you'd need to remove your helmet, and I definitely do not recommend that. At a height of 50 kilometers above the surface, visibility is poor. You'd hardly be able to see anything. The incredibly thick atmosphere would block views of this planet and its tens of thousands of volcanoes. The atmosphere is mostly made up of carbon dioxide, and because it's so thick, it traps heat on the planet's surface, keeping it nice and toasty. Just how toasty are we talking? You're gonna find out the hard way. As you descend another 15 kilometers, the haze would begin to clear. The world below would finally reveal itself. A rust-colored surface covered in mountains and volcanoes. Looks like this volcano is still active. You'd fly around a little to collect some samples and take in the view. Yep, the atmosphere is mostly carbon dioxide with traces of nitrogen. That checks out. Okay, well, let's see if you can land here. This looks like the spot.
Mission Control, am I clear for landing? Mission Control? Looks like there's no signal. Initiating the landing sequence without clearance. Fingers crossed.
Landing your spacecraft would kick up clouds of dust that would take several minutes to settle down in the soupy atmosphere. As it clears, you'd look up into the sky, but you wouldn't find the familiar yellow circle of the sun. On Venus, it always looks like dawn, no matter what time of day it is. That's because the Venusian atmosphere only lets about 10% of the sunlight that hits it reach the surface. But wait, what were we saying earlier about the space probe that landed on Venus? Oh yeah, Venera 13. This Soviet probe made its fatal landing back in 1981. It survived the descent and lasted for a whopping 127 minutes. That's longer than any other spacecraft that had made it to the surface. But then, Venera 13 gave way to the violent, uninviting environment of this hell. It was likely crushed under extreme pressure. Or it melted. But it's too late to turn around now. You've lived through the 1-hour-long landing, and you're so close. All you need to do to complete your mission is to spend 5 seconds out there. Yeah, out there. In the most extreme environment you've ever been to. You made it! Whoa, the atmosphere is so strange. You can hardly lift your arms. Even though Venus has about the same gravity as Earth, you'd be feeling the sheer weight of its immensely dense air. It would feel like you were walking through water. Very hot water. And you'd be glad you were wearing so much protective gear. A quick look at your thermometer would tell you that it's a sweltering 475 degrees Celsius out here. That's hot enough to melt lead. Your pressurized suit would be working hard to keep you safe. Without it, you'd be crushed under all that pressure before you could even complete your mission. This isn't so bad after all. Hey, if a spacecraft could last over 2 hours, some 40 years ago, well, you and your shiny new gear can survive longer, right? Venus is right here for you to discover. Just take a few more steps. Suddenly, something distracts you from the first ever first-hand human analysis of Venus's surface conditions. Your protective suit breaks. The drastic pressure shift would immediately make you feel like you were deep underwater. With an atmospheric pressure 90 times that of Earth, Venus would be crushing you from all directions. At the same time, you'd be struggling to breathe in an atmosphere without any oxygen. Any atmosphere you did manage to inhale would scald the inside of your mouth and the top of your throat. Unless you could scramble very quickly back to the safety of your spacecraft, you'd be dead within seconds. Hey, it could be worse. High above you, sulfuric acid clouds would be raining acid. But in this unbearably hot environment, the toxic rain wouldn't reach the surface. It would evaporate long before that. So at least you wouldn't have to worry about acid dissolving your skin and bones. That would be kind of gruesome. The crushing pressure of Venus reminds me of the pressure I'm constantly under to educate and entertain you on a daily basis. Just kidding. We only have fun here at What If. Why take yourself so seriously? Okay, the other theme today is specifically 5 seconds. In all these videos, I'll be leaving you somewhere for just 5 seconds, but it's amazing what absolute mayhem can take place in a mere 5 seconds. Stick around till the end when we make Carbon take a 5-second break. It's not pretty. Okay, next though, we take a swimming trip to Titan, Jupiter's largest moon. This ain't your average beach resort. You can forget about crystal clear turquoise waters here, and don't forget to pack your water wings, your floaties, because otherwise you'll sink like a stone.
Titan.
The most majestic of Saturn's many moons. And the most promising for life, too. It's got a beautiful view and liquid lakes on its surface. The only problem is those lakes aren't filled with water. They're filled with liquid methane. Your mission is to take a 5-second dip in one of them. Of course, you'd have to land on Titan first, so buckle up for the most epic adventure of your lifetime. Titan is far. Even at its closest to Earth, this icy moon is still 1.2 billion kilometers away from us. You'd be looking at roughly 7 years of travel alone in a spaceship. You'd need lots of provisions and a super advanced life support system. You know, it would be good if you made it to Titan and didn't freeze or suffocate somewhere in the middle of the solar system. Yeah, that's not going to happen to you. Just sit back and enjoy the ride. Seeing Saturn up close is amazing. Definitely the most spectacular of all the ringed planets in the solar system, but hey, enough sightseeing, it's time to make your way to your destination. Titan is unique in many ways. For one, it's larger than our moon. It's even bigger than Mercury, the smallest planet in our cosmic neighborhood. It's the only moon that has a thick atmosphere. It's also the only one that's covered in liquid lakes, rivers, and seas. And sometimes it rains here too. Descending on Titan would take you about 2.5 hours, and you couldn't just land anywhere. Like I say, Titan is covered in lakes, so unless you wanted to dip your entire spacecraft in liquid methane, you better choose your landing site carefully. Let's try this again. Okay, now that you've properly landed on Titan, let's go explore this icy world. This moon of Saturn might look a lot like Venus, but it's not as hellishly hot. Titan is one of the most hospitable places in the solar system. Yeah, its gravity is only 14% of Earth's, but its thicker atmosphere makes it possible for you to walk there even without a spacesuit. But I wouldn't recommend that. You'd need the spacesuit to keep you warm. Titan is very far away from the sun, so it doesn't receive as much warmth as we do here on Earth. You'd be taking a brisk stroll at a chilling minus 180 degrees Celsius. Well, you wouldn't exactly be strolling. More like bouncing around? Yeah, thanks to Titan's weaker gravity, you'd feel a lot lighter and could jump higher and move with less effort. Now, Titan's atmosphere is mostly nitrogen, very similar to Earth's, but you still couldn't breathe on this moon because, well, that's where the similarity ends. While 95% of the air here is nitrogen, the remaining 5% is methane. You'd need an oxygen tank to survive even 5 seconds on this world. Yeah, it's not just the lakes that have methane in them. There's plenty of methane in Titan's clouds, and sometimes it even rains methane. But this rain isn't anything like you've seen on Earth. It would be more like rain in slow motion, thanks to Titan's lower gravity and thick atmosphere. On Earth, raindrops fall at about 9 meters per second, but on Titan, their speed is only about 1.6 meters per second. That's 6 times slower. It would be pretty cool to walk in the rain here. But hey, you didn't come here for a walk in the rain. You came to take a dip in Titan's lakes.
I wouldn't do that if I were you.
Oh, excuse me? Who's here?
Alright, let's do this. What's up, everybody? I'm Chase. I'm from the year 3050. And for the last, well, things are a bit wobbly where I come from. I've been traveling through space and time a lot. Thing is, I die a lot. Like, a lot. It's kind of like my special power. It all started when I touched this shiny alien cube. Now I can jump between worlds, dimensions, time, and when I die, I always come back. I'm still trying to figure that one out. I think it has something to do with Einstein? I don't know. It's pretty cool. I jumped on the rings of distant planets, been the guest of honor at an alien feast, and not in a good way. And there was that one time I accidentally started an interstellar war. Cute. But now I'm here on Titan to stop you from doing, whatever it is you're doing. Because you only live once, unless you're me. So, your mission is to take a swim in one of these methane pools? Let me break it down for you. First off, this ain't no spa day. It's like diving into a freezer. Titan's got this super chilly vat going on, you know what I mean? At these temperatures, water's harder than concrete. But methane and ethane, they're like, yeah, it's cold, bruv, but like, we can still chill in liquid form. And so they gather up in these cool little pools.
Okay, I knew that too.
Sorry, no interrupting. I'm still just getting to the good part. Now, let's say you're wearing that fancy spacesuit. Good news, you won't freeze instantly into an astronaut popsicle. Bad news, that suit's gonna float. If, for some wild reason, you decided to take the plunge without the suit, well, that's it, my friend. Lights out! You see, the intense cold would freeze you down to your bone. You couldn't move a muscle. And then, the lack of oxygen would get jump. But 5 seconds with the spacesuit on, we'll definitely survive. Probably. Let's test it.
Okay.
Seems like someone's spacesuit can't withstand the cold. Someone needs an upgrade. It's so refreshing out here. I think I'll just stay another 5 seconds just to really enjoy it. Hot.
Chase?
Don't worry. These sparks are supposed to happen. Oh, it's like a stabbing, burning feeling.
It appears that the cold temperature cracked his suit and methane reacted with the oxygen tank inside it. He should have read about this in the mission brief. Well, just leave him here, I guess? Anyway, the mission is a success. The only thing left is to figure out how to get home. Imagine if all the Earth's oxygen disappeared. Not forever, just for, say, 5 seconds. Would we just hold our breath? What would happen to the atmosphere? What would happen to the environment? This is What If, and here's what would happen if the world lost oxygen for just 5 seconds. Take a nice deep breath. Feel how satisfying that is? What you're breathing in is oxygen, and it takes up roughly 21% of our atmosphere, with 78% being nitrogen. Although it's not the most abundant gas in our atmosphere, it is the most important. Without oxygen, plants, animals, water, and us humans wouldn't be where we are today. 5 seconds may not sound like a whole lot of time to be without oxygen. Most of us can go at least 30 seconds without taking a breath, so it would happen too fast for your body to even notice. Your breathing would actually remain normal, but as for everything else, not so much. In just 5 seconds, the Earth would look completely different. Without oxygen, you can say goodbye to the Hoover Dam, the Pantheon Dome, and anything else made of concrete. These structures would instantly collapse. Oxygen acts as a special binding agent to concrete. Without it, concrete is just dust. Speaking of buildings, any untreated metal would instantly be fused together. This is because there's a layer of oxidation on metals that prevents them from welding together. Without that layer, metals would instantly bind to each other. If you happen to be relaxing at the beach at the time, expect a severe sunburn. The ozone layer, our protection against the sun's UV rays, is made of oxygen. Take away the oxygen and the Earth would become extremely dangerous. There would be nothing protecting us from the sun's UV rays. In addition to a sunburn, our inner ear would explode. Losing oxygen means losing 21% of our air pressure. A change in air pressure that drastic is equivalent to being at sea level and dropping down 2,000 meters instantly. Our ears wouldn't have enough time to adapt. Having a good time yet? Well, don't expect it to last long. Without oxygen, there's no fire. The combustion process in vehicles wouldn't be able to occur.
any mode of transport that isn't electric will automatically fail. Planes will fall from the sky, and millions of cars will be stopped in their tracks. The sky would be completely dark. Before it hits the Earth, light from the sun bounces off multiple particles in the air. Without oxygen in the atmosphere, there are less things to bounce off, and the sky will appear dark. Oh yeah, and while all this is happening, the Earth's crust would completely crumble. That's because Earth's crust is made up of 45% oxygen. The crust would crumble and continue to crumble until there's nothing left, sending you and everyone on the planet into a free fall. Sound like fun? Probably not. But luckily, you can take a deep breath of 21% oxygen knowing this will never happen.
Okay, I wasn't expecting that. Thought maybe more of a holding my breath scenario, not the Earth crumbling to dust and disappearing. So things aren't always what you expect them to be, right? Well, then just imagine this next one. What if the Earth hit the boiling point for 5 seconds? I guess it would be pretty hot, you say, but 5 seconds? I can take that. Well, think again. Get ready for some serious burns and the instantaneous death of organisms. Let's turn up the heat and bring the entire planet to a boil for 5 whole seconds. How would this apocalyptic heat wave affect the environment? What would this do to all living things on Earth? And would you be doomed to explode from the inside out? This is What If, and here's what would happen if the Earth reached the boiling point for 5 seconds. While you might complain about roasting in the blistering heat of a summer day, the average temperature on Earth is around 13.9 degrees Celsius. Compare that to the hottest places on the planet, like China's Flaming Mountains or Iran's Lut Desert, which have recorded land temperatures around 70 degrees Celsius. And that's still not nearly as hot as a cup of boiling hot tea. Water reaches its boiling point at 100 degrees Celsius. This is the point where liquid water turns into water vapor. With 71% of the Earth's surface covered in water, life is about to feel like you're stuck inside one giant kettle. If temperatures suddenly spiked, you wouldn't necessarily need to worry about everything going up in flames. At least not right away. Wood ignites at around 300 degrees Celsius. And while you could be imagining that all the water in the oceans would suddenly boil away, don't worry, that wouldn't happen either. That's because the deeper you go into the ocean, the higher the pressure. And this affects the boiling temperature. Already at 10 meters below the water's surface, the boiling point becomes closer to 120 degrees Celsius. So, not all the ocean water on Earth would turn into vapor, but in the steamy, shallow waters, most living organisms, plants, and animals would likely spend these 5 seconds boiling to death. Maybe only thermophiles, microorganisms that thrive at temperatures up to 108 degrees Celsius, would survive unscathed. And you wouldn't enjoy this brief apocalyptic window of time very much either. The steam would scald your skin and seriously injure your eyes. Even just taking a breath during this time could cause mucous membranes in your mouth, nose, and throat to suffer severe burns. If these burns were deep enough to destroy tissues, you could end up developing rhabdomyolysis. This condition could result in permanent damage to your heart and kidneys, or even death. But that's not even the worst. There's also a lot of ready-to-boil water somewhere else. In your body. Yeah, you are about 60% water. If this water was to turn into steam, you'd know it. Your body's water would suddenly increase in volume by 1,600 times. Well, you and anything else that has water inside it would simply explode from the inside out. But maybe you'd be lucky and 5 seconds wouldn't be long enough to detonate you. Well, that wouldn't mean that life following the worst heat wave imaginable would go right back to normal. No, immediately after the 5 seconds, the global temperatures would drastically drop. And all that water vapor would transform back into liquid. You'd better be prepared for some crazy flash flooding and extreme weather. And that steam turning back into water would bump the temperatures in the surrounding environment. Things could heat back up enough that polar ice caps and glaciers would melt even faster. When all that ice disappeared, the sea levels would rise by about 70 meters. So even though the Earth would only have boiled for about the same amount of time it takes for one big yawn, it would create circumstances where major cities around the world could become flooded and uninhabitable. Millions of people could die in the aftermath. And that's if they didn't already turn into spontaneous steam bombs. If this is how you picture walking on Uranus, you're wrong. Let's start this again. Are you ready to take a trip to the outer regions of the solar system? To explore the weirdest planet in our cosmic neighborhood? To venture down into a place that's never been studied up close by any spacecraft? Buckle up for an icy, violent, and stinky adventure because your mission is to spend 5 seconds on Uranus and come back. If you can. Traveling to Uranus would be a long, strange journey. First, you'd have to spend 10 long years in a spaceship, speeding toward the outskirts of the solar system. If you're lucky, you might even pass Jupiter and Saturn on the way. Just make sure you pack enough food and fuel. Well, there are some things you should know about this world. Uranus isn't a rocky planet like Earth. It's an ice giant like Neptune, and it's the only planet in the solar system that spins on its side. It spins fast, too. One day on Uranus is just 17 Earth hours. Of course, you wouldn't last that long on it. Not a chance. Once you arrived at your destination, you'd still have some work to do to get close to this giant blue planet. You might have to dodge Uranian rings. Yeah, Uranus has rings. 13 of them. They aren't big and majestic like the gorgeous rings of Saturn. The outer rings are bright and easy to spot, but the inner rings are narrow and dark. You'd have to navigate this part of the trip with the utmost care. As you made your way through the dusty rings of Uranus, you'd see its glorious blue atmosphere up close for the first time in human history. Take a moment to enjoy the...
Uranus. What an oddballs planet. You know, I flew by it a month ago. That was fun. You wanna know why nobody, and I mean nobody, has ever tried to land anything on the surface of this beautiful planet? Because Uranus has no surface. It's just a swirling ball of toxic gas compressed around a small, icy core. Oh, and wait till I tell you why those gases on Uranus are toxic. Yeah. Gross.
Yeah, okay, thanks for your input, Chase. It's true, Uranus might have a calming blue color, but it's cold and toxic. Not the kind of blue planet you want to visit.
That's okay. I think you should sit this one out. Here I go! Woohoo! It's brisk here. Oh, Rico, what's the temperature?
Minus 224 degrees Celsius.
Oh, that's cold. That explains why I can't feel my fingers or my toes. or the rest of my body. Okay, well, at least those 5 seconds are done. Okay, Rico, it's time to go home. Let's bounce.
Impossible. If my calculations are correct, you will reach the icy core in 54.4 minutes.
So? What? That wasn't the plan. And what's 0.4 of a minute? Use seconds, you dumb bot!
I suggest you take this opportunity to study the planet up close and report back.
Well, I suggest you take this opportunity and stuff it up your charging port!
I don't have a charging port.
No one cares, Rico! No one cares! Honestly, this sucks. Uranus smells like shit.
Yeah, the reason Uranus smells so bad is that the clouds in its upper atmosphere are partially made up of hydrogen sulfide. Not only does this make the planet stink, but it's also pretty toxic. Whatever you do, do not inhale it. If you did, it'd make you faint and die instantly.
What? It would have been real nice to know this before I jumped.
Yeah, well, after falling through the stinky clouds at the top atmosphere, you'd find yourself in the mix of 82% hydrogen, 15% helium, and a bit of methane. Methane gas is what gives Uranus that bluish-green haze because it absorbs light at the red end of the spectrum.
Huh, these clouds are getting a little weird. Kind of floaty.
Yeah, the atmosphere on Uranus is very dense. After passing through its top layer, you'd stop falling and start swimming in it instead. As you were paddling deeper, you'd start getting pelted by frozen gas crystals.
Huh?
But at least the temperature would be rising.
I don't know about that. I don't feel warm at all. Rico, give me the stats.
The temperature around you has indeed gone up to minus 208 degrees Celsius. My calculations show you can expect minus 153 degrees Celsius in the lower atmosphere.
Cool. Great. Ow. Ow. What is that?
That? Well, that's diamond rain. Yeah, on Uranus, it rains diamonds. That's because the Uranian atmosphere is rich in methane, a single carbon compound. Under extreme pressure, the methane molecules break apart and crystallize into diamonds. But the worst part is the wind. You'd be dealing with winds gusting at speeds of up to 900 kilometers per hour. That's 3.5 times stronger than a Category 5 hurricane here on Earth.
Rico, it's getting tight in here. Oh, I can hardly breathe. And when I do breathe, it smells like ass.
Of course. The pressure is 100 times greater than the atmospheric pressure at Earth's sea level. You are approaching the mantle.
The good news is you wouldn't splatter on anything because there's not much in the way of solids on Uranus. The Uranian mantle is made of water, ammonia, and methane ice. It would be pitch black in here, and thanks to the extreme gravity, you wouldn't be able to move a muscle. And it would still be incredibly cold. What you should be worried about is the immense pressure that would be rapidly increasing the closer you got to the planet's center. It would squish you before you ever got to the core.
Ah, being crushed by Uranus. I always thought it would be way nicer.
Well, in this extreme pressure environment, your carbon-based body could turn into diamonds and drop down into the core. What a spectacular way to finish this one-way trip to the center of Uranus. Chase? Oh, right. Hey, it's not a What If live stream until we mention Uranus. Yeah, it's actually pronounced Uranus. Okay, go ahead, say it out loud. Feel better? Hey, you like my hoodie? It's a nebula, the gas and dust thrown out by the explosion of a dying star. Well, you can get one of your own at the What If merch store. Of course you knew there'd be a sales pitch. You're probably surprised that it took me this long to get to it. It's because I respect you. Check out the What If store at shop.underknown.com. You can get this sweatshirt, this coffee mug, a copy of our book, The What If 100, hats, hoodies, stickers. We got it all. Okay, our next video is about Mars, the planet that gets all the hype, has for years. But let me just say, I was totally into Mars before it was cool, so Now, is it a habitable planet? Maybe not. Would it be a good place to relocate once we've completely rendered Earth uninhabitable? Well, at least it's close by. Could you last 5 seconds on it? Well, have a look. Ah, Mars, the red planet, and our potential new home. Well, Mars isn't as hospitable as it sounds. It's really inhospitable. It might be a balmy 20 degrees Celsius during the day, but at night, the temperatures can drop to minus 153 degrees Celsius.
Okay, if you don't know what minus 153 degrees Celsius is, it's intensely cold. It's like minus 243 degrees Fahrenheit. It's the type of temperature that will give you frostbite in seconds. In minutes, you'll die from hypothermia. Seriously, guys, learn the metric system. Also, we do the conversion for you in the closed captions.
And if you think Uranus smells bad, well, that's because you haven't been to Mars yet. Yeah, the red planet smells like rust and gunpowder.
But when I wear my helmet, all I smell is me, and I smell pretty good. Most of the time.
Well, you wouldn't be able to breathe on Mars anyway. The planet barely has any atmosphere. Most of it is carbon dioxide with only trace amounts of oxygen. Luckily, this time we aren't sending you to Mars. We've decided to sacrifice Chase for this mission.
What did you mean by sacrifice?
I mean send. We sent Chase up to set up a base on Mars and report back. Hey, he made it! Welcome to the Red Planet.
Kinda nothing here, huh? I thought there'd be more stuff, Rico? Any ideas?
I detect no breathable air, high levels of radiation exposure, low pressure, and frequent dust storms. If you want to survive on Mars, you must build a habitat.
Great idea. How long will that take?
With the materials you transported aboard the Starship, I calculate it will take about 3 months to assemble a simple base.
That's not so bad. I better get moving.
Now, building a habitat on Mars wouldn't be so simple. It's got to be airtight and insulated to protect Chase from radiation and Martian dust storms. It also needs to have a sustainable life support system to manage air, water, and waste. And, of course, Chase will need to get power from solar panels.
You don't want to know where I get my drinkable water from. But I'll tell you anyways. I could extract water from the Martian soil or atmosphere, but it's so much work. Instead, I recycle water from things like sweat and pee. I just try not to think about it.
The sensors are picking up a micrometeorite headed straight for the base. Potential hazard detected.
Don't sweat it, Rico. We got enough water. Base is fine. I built it myself. Here, let me give you a tour of my crib. Welcome to the fanciest pad on the planet. Over here is where I sleep. And over here is where I eat. And over there is a window. And this is my luxury first aid corner, in case I get hit by like a dust storm. Those babies travel at like 100 km/h. They could easily slice through my spacesuit. Oh, you gotta see my Michelin star greenhouse. It's 5 stars because it's rated out of this world. It's my favorite place in the base. Only thing is, I had to build it unattached to my main living quarters because Rico forgot to include a tunnel in the first base plan. So now every time I gotta go check on my plants, I have to go outside. It's exhausting. That's why I don't bother to take off my helmet when I pop into my habitat. I'm all about efficiency. Plus, it's a lot to animate, actually. Check out these potatoes. They look pretty good. Take that, Matt Damon.
Micrometeorite is approaching the base. I calculate the chance of it striking the habitat has 87.42%.
Rico, silencio, por favor. I'm recording a YouTube video, my friend. Come on, and what did I tell you? Round the numbers. Okay, where was I? Oh, yeah, potatoes. It takes a lot of work to grow anything on Mars. Taters aren't my first choice. I'd grow burgers if I could, but we work with what we got. I keep my greenhouse nice and pressurized and at a comfy temperature of 16 degrees Celsius. And for those of you who hated the recycled pea stuff, you're gonna love this next part because as a fertilizer for the Martian soil, I use a super special ingredient, my poo. Not because I'm a sicko, but because Martian soil is literally garbage, figuratively speaking. It smells pretty bad in here. Ugh, but at least it doesn't smell as bad as Uranus.
Danger. Micrometeoroid has breached the habitat. You must go there immediately.
What? Ah, damn meteoroid. Sorry guys, I gotta go check this out.
Your helmet has sustained minor damage.
This is my favorite helmet. Rico, do I have a spare somewhere?
You have an extra helmet, but I have bad news.
Uh-huh. What? What now?
The extra helmet is back at the habitat.
Of course. Of course it is. Are you kidding me? 3 months on Mars! And I just finally start getting this thing working and Mars has to ruin everything! Well, at least I have tape around here somewhere. Be back in a minute. Here, this should work. Rico, how's that storm looking?
Not good. A dust storm of this type, it can last for days.
Oh, great. That leaves me no choice. If I don't make it back in time, I'll lose everything and die. And I can't die now. I just finished building this sweet, sweet bachelor pad.
It's only a 5-second walk for you to reach your living quarters.
Okay, come on. It's only 5 seconds. You can do this, Chase. You can do this. Get your head in the game, boy. This helmet is useless. I'll go without it. 5 seconds to get back home. I can handle a little bit of frostbite.
I highly advise you don't do this.
Okay, well, if I don't make it, I'll see you guys on my next adventure. Chase out.
Looks like the atmospheric pressure killed him before the frostbite could. Didn't I say going out there without a helmet was a bad idea? Yeah, don't try this on your own. And don't worry, Chase will be fine. It's kind of his thing. He dies. A lot. But he always returns for another adventure.
The sky is falling! The sky is falling!
Get a grip! The sky isn't falling. It's getting sucked into outer space. And so are all the oceans, and the trees, and cars, and roads, and bridges, and the Earth's core, and you. So get a grip, and hold on tight.
Hang on, kid!
You're in for a wild ride. This is What If, and here's what would happen if we lost gravity for 5 seconds. Unless you're an astronaut, you probably don't spend a lot of time thinking about gravity. We all take gravity for granted, and it would be hard not to. Aside from a tiny sliver of the world's population, most humans don't know a life without gravity. From the universe to our solar system to each planet, all the way down to our own bodies, gravity holds everything together. But since we tend to see gravity as a given, it's hard to imagine just how helpless we would be without it. Until it's actually gone. Gravity is an attractive force between any two masses. The greater the mass, the greater the gravity. The greater the gravity, the stronger the pull. Gravity is the reason why Earth rotates around the sun, why we experience high and low tide, and why we can walk on this planet without floating away. Most importantly though, gravity secures our atmosphere, holding in the air we need to breathe.
In fact, there are a lot of things we can thank gravity for. So many, though, that if we tried to list them all here, we'd probably end up with a video longer than Titanic. So, just to give you an idea of how important gravity is in a really short amount of time, we're going to take it away from you. But not for too long. Just 5 seconds. Are you ready? With the world still spinning at its usual 1,600 km/h speed, everything that isn't secured firmly to the ground would go flying. Cars, boats, trains, planes. Well, obviously, but not like they normally do. More like this. The Earth spins faster along the equator, so the impact of zero gravity would be felt hardest there. At the equator, you could experience winds almost 6 times stronger than the ones produced by Hurricane Katrina. That means that in just 5 seconds, you could be blown as far as 2.3 kilometers in any direction. And not just you, there will be plenty of people, objects, and animals to look out for. Not to mention trees, soil, and mid-air floods from the world's ponds, lakes, rivers, and oceans. At the same time, the gases in the atmosphere would drift out into space. Not only are we now losing huge amounts of oxygen, but the sudden and sharp drop in air pressure would instantly shatter everyone's inner ears. And then there's the planet itself, which is literally held together by gravity. Without gravity, the pressure of the Earth's inner core would cause the planet to expand. It's not like 5 seconds without gravity would cause the world to explode, but even a 5-second expansion of the Earth's inner core would cause some major earthquakes and trigger huge volcanic eruptions. Add one more item to your list of dangerous things flying through the sky: lava. Out in space, the planets in our solar system that normally orbit the Sun would instead start drifting away from it. Earth would follow its neighbors at a speed of 30 kilometers per second. In just 5 seconds, it would have traveled 150 kilometers. That's not far enough for our planet to be out of the habitable zone, but how habitable would Earth be after 5 deadly seconds without gravity? When gravity was restored, you'd hit the ground hard. If the impact didn't kill you, or if you weren't crushed by a heavy object, you would still be severely injured.
My back! Oh, my back!
Hopefully, you'd catch your breath in time, with gravity pulling oxygen back down to Earth and bringing the atmosphere back around the planet. But there would still be earthquakes and volcanic eruptions as the Earth's core becomes compressed again. And there would still be massive flooding due to the significant displacement of the oceans. The number of casualties would be astronomical. Not just from flying debris, lack of oxygen, or simultaneous natural disasters, but because in those 5 seconds without gravity, the Earth's crust literally opened up and swallowed several major cities. So yeah, a lot can happen in just 5 seconds, and that just goes to show how essential gravity is to life on Earth and beyond. You may think you're special, and you most certainly are, but just remember that you're part of something bigger than you, and that's what keeps you grounded.
Yeah, I know I said these would all be 5-second scenarios and that was a story about 10 seconds. I lied. I wouldn't be lying though if I were to tell you about a great new show we've put out, especially for kids. You know, at What If, we try to make videos that appeal to everybody, but of course some of the topics can be a bit complicated for young kids. That's why we started a branch of What If just for kids, and called appropriately What If Kids. It's hosted by my buddy Cosmo, a little cosmic robot. He takes some of the same what if ideas we cover here and breaks them down a little bit more so that they're easier for kids to comprehend. It's based on the school curriculum for grades 1 to 4, but suitable for kids of all ages, yourself included. Check it out at YouTube/whatifkids. Birthday balloons falling limply to the ground. Satellites, medical scanners, and TVs fading to black. And twinkling stars in the night sky disappearing one by one. All in just 5 seconds without helium. what would the loss of helium do to your body? How would the rest of the universe react to this molecular on-off switch? And could this bring about the end of our solar system? This is What If, and here's what would happen if all helium disappeared for 5 seconds. Hey, helium isn't just your party balloon filler-upper. It's the second most abundant element in the universe, and the second lightest, too, behind only hydrogen. Helium can be found on both planets and moons, but most of all, stars. After all, it was discovered in 1868 by astronomers who observed a yellow light in the sun's corona during a solar eclipse. That's how it got its name, from the Greek god Helios. And even though this gas isn't something you need for your biological functions, it's an important part of your everyday life.
I really shouldn't be doing this.
It's used in the lasers of barcode readers, medical machinery like MRI scanners, and scientific research equipment like CERN's Large Hadron Collider. And it also helps prevent stars from exploding. So, would 5 seconds without helium lead to the biggest interstellar fireworks show of all time? Well, the moment that helium disappears from the universe, you'd barely notice anything. Our atmosphere contains almost no helium, so you'd keep on breathing without any issues. But hopefully you weren't in the middle of an MRI scan when all of this goes down. These use a ton of energy and have superconducting magnets that need to be kept cold. Very cold. Without the minus 269 degrees Celsius chill of liquid helium running through the wires, the magnets would overheat. If you were in the machine at this moment, you could get some serious burns. Scientists working with CERN's Large Hadron Collider would immediately run into a similar issue, except they'd suddenly lose 120 tons of liquid helium. And now they'd have increasingly hot magnets steering the machine's particle beams. And of course, the worst thing that would happen is the rapid deflation of every birthday balloon on the planet. That would make for a lot of very sad kids. Okay, maybe this wouldn't be the worst. Because none of these problems would compare to what would start happening around the rest of the universe once all the helium disappeared. In the core of our sun, helium is produced by the nuclear fusion of hydrogen atoms. And not just a little bit either. The sun produces 700 million tons of helium every second. This nuclear fusion process exerts an enormous amount of outward pressure. And without being contained somehow, this would explode, just like a hydrogen bomb. Good thing there's inward pressure formed by the sun's massive gravitational pull. This attraction of the gas mantle surrounding the core provides enough of a balance to keep things from blowing up. But if all the helium vanished, a large amount of the sun's mass would be gone, and with that, it would have less gravitational pull. This would upset that precious balance. So now, our sun would be on the verge of exploding, and you could count on that being very bad news for you and everyone else back on Earth. Now, with any luck, this wouldn't happen. The 5 seconds would be up, and our sun would maintain its pressure as all of its helium is once again restored to its rightful place. Sure, MRIs and the Large Hadron Collider could be out of service for a while, but at least you could spend the rest of your life counting your lucky stars. Although, make sure you keep an eye open for which stars those are. Looking up, you could see a permanently darker night sky. Some stars didn't fare as well as our own. And as their light travels, you could see evidence of their explosions for many years to come.
2, 1.
This is carbon. And of all the chemical elements in the universe, it's one of the most plentiful. So, what would happen if all of it suddenly disappeared for 5 seconds? How would this little change affect our universe? Could it reverse climate change here on Earth? And why would your body never be the same again? This is What If. And here's what would happen if carbon disappeared for 5 seconds. Carbon is the 4th most abundant element in the universe, and it's part of many things, including you. Yeah, that's right. Your body is 18% carbon. That's a pretty big chunk of you to lose, even for 5 seconds. In your body, carbon bonds with other elements to form proteins, fats, sugars, even your DNA. So, if carbon suddenly disappeared, would you disappear too? You might think that 5 seconds without carbon wouldn't be long enough to wreak havoc in our universe, but let me tell you, once all the carbon disappeared, nothing would be the same again. Let's go from big to small. First, the universe. Space dust that surrounds stars is made of elements like carbon and iron. This dust is clumped together by the strong winds coming from stars. And eventually, these clusters of dust form into planets. Many planetary systems in the universe are carbon-rich. That means they could have graphite crusts, carbon monoxide atmospheres, and even oceans of tar. Without carbon, these worlds would only be silicon and oxygen. The planets would crumble and turn back into space dust. Maybe they would reassemble back into planets again once all the carbon reappears 5 seconds later, but this would take millions, possibly billions of years. And whatever life has formed on these worlds would have to begin evolving from ground zero. Our planetary system is a little different because it is oxygen-rich. It has twice as much oxygen as carbon. That's because when our solar system was forming, all the carbon got blown into deep space. Yeah, at first, the Earth didn't have any carbon in it. The carbon that made life possible on Earth came from interstellar comets and asteroids. And if this extraterrestrial carbon were to disappear for 5 seconds, some bad things would happen. First, the carbon cycle would immediately stop. Under normal circumstances, carbon cycles through living things, water, and the atmosphere. This is happening all the time through things like photosynthesis, decomposition, and respiration. So if we stopped eating, digesting, and breathing carbon, sure, we'd be reducing our carbon emissions by a lot, but in this case, it would be too much. Without any carbon dioxide in our atmosphere, we'd lose the greenhouse effect, which keeps our planet warm and makes life possible. Our climate would radically change. The average temperatures would plummet and everything would freeze. Solids made of pure carbon like diamonds, coal, and graphite would disappear immediately since that's all they are. You'd find that washing your clothes, dishes, and body would suddenly be more challenging too. Carbon is a water-soluble additive that creates the soapy lather you love so much. Without it, most of these household products would become mostly just water. But you know what? Cleaning your body might be the least of your worries. Carbon is the second most abundant element in your body, and your primary energy source comes from breaking carbon bonds. Yeah, that means your body wouldn't be able to extract energy from compounds like glucose. For that matter, glucose wouldn't exist anymore. It would become water. And carbon is the backbone of your DNA's structure. Without it, your DNA would fall apart and wouldn't be able to tell your cells how to grow and function. Almost 2 trillion of your body's cells divide every day, which is essential to your life. Take carbon out of the mix and these cells would stop working. And this wouldn't only affect your DNA. If carbon disappeared, it would affect all the proteins, fats, and muscle tissue in your body too. Without any carbon in the universe, your body would fall apart. You'd just be a sloppy mess of water and inert compounds. Ugh, somebody bring a mop. You, the Earth, and the universe would be destroyed in those 5 short seconds. Maybe 5 seconds without gravity would be easier to live with. Okay, thanks for joining us today on this fantastically freakish foray through our 5-second frights. Hope you enjoyed it. Hope you learned a lot. Don't forget about our merch store. Don't forget about Cosmo and What If Kids. We'll be back soon with another What If. Hey there, welcome to another live stream of What If? Yeah, live stream. This week's theme is everything that could kill you in seconds. Sounds about right for What If. No matter what happens, everyone usually dies at the end of one of our stories. Today, we'll look in on what if we lost all oxygen in the world for a